Hello everyone, this is Mr. Khan from Pakistan. Today we are going to cover a small topic, how to find out static pointers of all libraries, and it is a very simple process, and we have been updating the static pointers of all libraries every season now, and we are also posting it in our group as well as in our channel. You can scroll up and see that. Let us show to you how you can find it. Just open up your game, attach cheat engine to it, okay. It is a very simple thing. Just select string mode and then search for something like this, lib/arm, okay, and make sure that it is like this. Scan first. Whatever you see, just go visit that, okay, in disassembly mode or in browse this memory region, whatever you like. I will use the browse this memory region, and here is an address of a library which is libdiscord connect stk android.so, something like that, but it should not have the other string here as unexpected e-machine, etc., etc. We are looking for a region that has all these libraries one after the other, and which does not have these empty regions above and below it, okay. So what we are going to do, the first thing that we are going to do is search for something like this, libanogs.so. Comparatively, you should get some small addresses, okay, and you can go ahead and look at all these regions one by one. And as I said, we are trying to find out a location in memory that has all these libraries loaded, but one after the other, okay. So if we go scroll up a little bit, we see some exported functions in memory. We are not looking at that. If you scroll down, we see other exported functions, k method, id, webweave, etc., send message. These are exported functions in memory, and each one of that function has some address. So we will go ahead and try to find some location in memory that has these libraries loaded, but one after the other, okay, in sequence. So here we see that we have libanogs, and there is another libanogs, there is another libgcloud, okay, and we can scroll up and down and see that there are only entries for libraries, okay. libgcloud voice, here is another one, here is another one, okay. So it means that this location, whatever we are trying to find, we are on the right track here, okay. So see that here is libanogs.so, and you can scroll up until you see the first entry of the library that you are targeting, okay. So the first entry I see for libanogs.so is this region, and if we go up a little bit, we see that there is another library loaded. Of course, libgcloud loads before libanogs.so, and if we go up a little bit, there are some other libraries loaded, and their entries are respectively present in the memory as entries here. What we have discovered is these entries presented here have two things. The first thing is their address in memory, whatever address they are going to point to in order to load this entry of this library from the file system into memory. So this is an entry, and there is some address which the game will use to load this library into memory from this location, from your physical disk. So what we can do before going into detail, the first thing that we are going to do is search for the header of the LibAnogs library, so that we know if we find a static pointer that it is in fact pointing to correct address in memory. So let's open the header of the library that we are going to target. So for me it is going to be LibAnogs, and mind it that I'm going to use 2.0 as example, and then in the later half of the video I will show to you how to find for 2.1, and using this information you can deduce and find for any library that you like in the future. We already know that for 32-bit libraries we have 52 bytes as the header bytes. So this is the first method. This also clears the confusion for you how to find out header of libraries, which some people post on UC and feel proud about that they have done a miraculous thing. It is nothing. It is in fact not even worth your time, but you can find out here like this. Load the library in HXT or any other hexadecimal editor like WinHXT or like IDA or like the hexadecimal feature of your Notepad++, anything, and just copy the first 52 bytes. So these 52 bytes, 16 bytes on each line, 3 times is 48 plus 4 is 52. 52 bytes of the start of each elf file, which is .so file, is its header if it is made in 32-bit, if it is compiled in 32-bit. If it is compiled in 64-bit version, then you have to copy the first 64 bytes. So we copy this because we are in the 32-bit mode of the library. Of course we are playing 32-bit games, so for others who are trying to find pointers for 64-bit version of the game, they should copy the first 64 bytes, and then we can convert into the array of byte mode and paste our library header, and then we can scan it. Make sure that when you are scanning, the game is running. So here is the first address which I'll bring down to my list, and then I'm going to add a description to it that this is the LibAnogs base address, just for clarification. And now I'm going to add an address manually. The first thing that you have to note about working in memory is the Endianness. Okay, Endianness. So there are two formats. The first is called little endian, the second is called big endian. Okay, in the big endian mode, all hexadecimal numbers are represented as is. As is means when you convert from any format to hexadecimal format, the number should be represented in memory whatever you see in your conversion program. Example is this. If you convert something like just for the sake of example, 789 in hexadecimal, it will be 315. So if we are going to convert 789 to hex, which is this one is in base 10, and we want to convert it into base 16, and we want to go into memory. So for little Endianness, so for big Endianness, 789 in memory is represented as will be represented as 03015. okay, but if you are in the little Endian format for any architecture that you are targeting, then 789 in base 10 will be represented inside memory as reversed, okay, in reversed order. So you will see it like this: 0 into 15 and then 0 into 03, and this reversing of the order of the bytes will be seen for all kinds of searches and all kinds of numbers. So if you are trying to find out what is the value of the iPad B, for example, and you already know that you have converted for example 120 degrees, then you can go ahead and convert 120 degrees, and you will see it as 78. So as it is a single byte, even if it is reversed, it will stay like that. But if you are searching for something else, like a number 6789, let's say, then inside memory you already know that what you are looking at. So in little Endian, in big Endian, you will see it as 85 and 1A, okay, but in little Endian you will see it as, sorry, I was a little bit distracted here. In the little Endian format you will see it like this, and in the big Endian format you will see it like this. Alright, so this is some basics of the ARM architecture which we are seeing here. All this memory you are seeing is in the ARM v7 version, okay, ARM v7. And if we see and search in Google, if you see ARM v7 and if you find out what is its Endianness, you will see that the ARM v7 uses the LE format, which is little Endian format, and this is used by ARM v4 up to ARM v7, okay. And yes, I was looking at some tutorials about FRIDA. Alright, so that's it for the basics. Then if it is clear now, let's look at the interesting bits here. In this memory you can see that from the dot 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 up to here, this is a string identifier. This is a string, okay, this is just an address of the physical location of your library. But if you go up here, from here onwards in the reverse format, or in here in the reverse format, you will see there are 4 byte 2 addresses that you can check to find out if they are targeting the if they are targeting the address or not. But you can also see it here too, here, okay, 40A00000, and you can see the location of this address as E0C1228. And this we have discovered that after this byte, the rest of the memory location represents just a string of the location of the library that the game is going to load into memory. But this location, it is already saving it as a static value, okay. And this is a static pointer because no matter how many times you are going to restart your game, this location E0C121F plus the 8 bytes here, this will always hold the address of the location of the loading of LibNox library inside the memory of the latest version of game loop. Alright, so let's try and add this address manually. Let's see if it is really pointing out to the correct location of LibNox or not. So we add the address manually, and because we are trying to read it as a pointer, so we click the pointer here, we add some description, pointer to LibNox, and then we are going to add our address that we are seeing here after clicking here. So this is 1F. After this becomes 20, okay, 1F. So if this is 1F, this becomes 20, 21, 22, 23, 24, 25, 26, 27, and this is 28. So the address is E0C1228, and then we are going to make it a hexadecimal value of array of bytes, and the length of the bytes should be 52 because it is the header. We click it, and we can see that this address points to the location of the library that we just targeted here. And you can expand this, and you can see that each and every byte represented by both the pointer and the header are exactly the same. Alright, so let's verify if we have found the correct pointer or not. Let's close the game, and then we are going to start it again here, and we are going to find out if whatever pointer that we just saved here is going to be pointing to the location of the library or not. Alright, so let's start the game again. And this time we are going to attach to the process of the game manually, because we cannot attach again with the script, because this table that we have saved here will get destroyed if we attach again with another cheat engine. So we want this table to be preserved. We can save it, but that will be a lengthy process. Let's do it manually. Alright, so let's go and search for the process of the game in process hacker software. And we already know that the correct PID will have the largest memory usage. We search here by I, and we see here that this process 6496 has the largest memory usage of 1 GB. We will convert it with calculator to find out the correct PID in hexadecimal format. This is 6496, so 6496 will become 1960 in hexadecimal, and we will attach it 1960. This one is the correct process. So we see that as soon as we attached the new process, the pointer is reading the correct address, okay, and we can scan it again if the header is also in the same location. The pointer tells us already that the pointer is pointing to a certain location in memory that has the header bytes of anogs, and we already see here that the anogs is loaded automatically on the same location that it was previously loaded on. So this is how you can simply find out any header just by eye, and this process is valid for any type of game that runs in Android and uses the Unreal Engine, and which uses already libraries, and it loads in this order. You can use the same process for finding libraries location in PUBG Lite, in Call of Duty Mobile, and also for Apex Legends, because all of these are using the same engine. If you want to go ahead and find out the locations or pointers for other libraries, like for example I want to find out where the TGPA library is going to be loaded, so I'll just write its name like this. Make sure that whatever you write is case sensitive. So before writing the name, make sure whichever library you are going to target, it has the correct format of the case, okay. For example, the libuE4 has UNES capital. Similarly, the libtgpa is all lowercase, which I have written here wrong, so we will correct that, and then we will search for it, okay, in all memory. So I have done a small mistake here, and then we have to do it as string, not as hex. Okay, you should find small addresses. Let's go and do it again one by one by browsing the memory region. We are looking at something like this. It has some entries here, but we are going to go to the first entry of the library that we are targeting. So if we scroll up, we see that there is a libcube hawk, and this is the first entry of the libtgpa. This is the second entry. So we are going to see and look at the first entry, and we are also going to find out that it has here the address of the location where it is going to be loaded. How do we know this? We can confirm it by using the AOB scan for this same library. Just open it with any hexadecimal editor of software. Copy the first 52 bytes, go to cheat engine again, and then search for array of bytes, paste it, scan it. Here we see that this is the correct address, not this one. This is the correct address of the library, and we can say that this is their TGPA base address. but we want a pointer to that address, and we are seeing it like this: 44800000 in reverse order in memory here, 44800000. So we are going to write a pointer here. This is going to be a pointer at which location? The location is here, E0C3FE8. E0C3FE8. This is going to be a pointer to hexadecimal array of 52 bytes length. We click it OK, and then we can see that we can verify that the AOB pointed to by this address is the same as the one that we have written here, and we have found the base address. So this pointer and these pointers are now our static pointers, and we can see here by double clicking that this one is for enobs and this one is for libtgpa. And similarly, the same format you can use to find for libuE4. I am not doing that because I want that to be a homework for you, so you can do it yourself. Okay, now I am going to pause the video, and then I am going to update to 2.1, and then I will show to you how you can do the same for 2.1, which has not been released yet.